Bismillahirrahmanirrahim. Good evening and welcome to Halogen Nightline. I'm Adira, your anchor for tonight. We have one shocking news story. The first one turns the joy of Eid night into sorrow as a house catches fires. Amidst the festive, our focus shifts to a recent house fire sparked by fireworks in Jalan Barat Jaya, Damansara. The celebration turns chaotic, swift action from firefighters armed with brooming extinguisher saved 30% of the house. Overseeing the operation was Fire Chief Yusuf Mikhail, directing a 30 minutes effort that utilized brooming fire extinguisher and extensive resources to combat the fire.
If you don't stop calling, then I can't let go. When you're drunk and saying that you need me close.
Hey Sarah, it's me, Iza.
Hey Isa, I tried my best to call you many times. Where are you? What happened?
Sorry Sarah, I was in the bathroom. What's the matter?
No, I'm just want to ask about Opa's house. I just read in news about.
Don't worry Sarah, only the kitchen got burned. Not the whole house. Firefighters handled so fast. Within 30 minutes, everyone is safe, including Opa.
Really? Was such a relief. Thank you, Isa, for letting me know about that. Take care, okay? And send my best regard to Opa.
You too, Sarah.
So,
Sarah?
Amira,
Yes, I am Dr. Amira.
it's me, Sarah. Is it interrupting you during your work?
I am at hospital attending my patient. What's wrong?
You know, I'm just curious about the bromine. What is it?
Oh, you got confused about the bromine? Don't worry. Bromine is one of the elements in halogen group, by which it is located in group 17 in periodic table.
Group 17? I'm still not clear about that. Can you explain to me?
You still not care about that? Don't worry. After I do my work, we will have like a little and vivid explanation about it. Okay, Sarah?
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I am teacher Hanis. So, have you ever come across into your mind about a bromine fire extinguisher, iodine disinfectant, a chlorine bleach, or fluorine in fluoride toothpaste in your daily life? If your answer is yes, that's a good start of picture of this lesson, because these are just a few examples of how group 17's elements are utilized. So let's dive into what makes this kind of group 17, or called as halogen, so special and commonly found in our surroundings. So student, in the periodic table's far right column, you will find a group 17, also known as the halogen group. These elements, including fluorine, chlorine, bromine, iodine, acetylene, and also tennessine, share their own similar chemical behavior like their name for forming salt with metal. So among them, the first four members, fluorine, chlorine, bromine, and iodine, are the ones that we bump most often in daily life, and also we also construct the chemical reaction in a lab, right? So meanwhile, for the acetylene and the tennessine, they are like the shy member of the group. Because why? Because they are rare. So in order to remember all these elements in the right order, I have like one simple mnemonic situation for you to memorize it. What is that? Flower in young children's hands are blooming in brown, making it more interesting and attractive despite the cost of only 10 ringgit. Imagine you want to buy a flower, but then you realize that this flower have a magical, because from the start, from the pale yellow, when you touch the flower, it's blooming into brown and fascinating colors that make you more interesting and attractive to buy that flower. And you are surprised because of what? Because the cost of the flowers only costs you 10 ringgit. So that's what makes it special and easy for you to understand and memorize this kind of element in predictable for group 17. So student, I still remember that just now I just said that group 17 are also known as halogen. So they are characterized by having 7 valence electrons in their outmost energy level. So this configuration makes them highly reactive as they tend to gain one more additional electron to achieve a stable octet configuration. Similar to the noble gas, this desire to attain a full outer shell influences their electronegativity or their ability to attract and bond with the other. Next, halogen exhibit as high electronegativity due to their strong pull on electron, making them capable of forming strong bonds with the other elements. So, the tendency to form diatomic molecules and gain an electron to complete their outer shell underscore their adherence to follow the outer rule, guiding them for the chemical behavior and also interaction. So that's why, and that justifies why group 17 element cannot exist as monoatom, they can only exist as diatomic molecule like Cl2. So, have you ever wondered about the unique physical properties of group 17, fluorine, chlorine, bromine, and iodine? So, these elements belong to group 17 of the periodic table and have some interesting qualities and also properties. So, let's take a look closer of what makes them so special. Are you ready? So student, let's take a look into the first physical properties of group 17. So the first element is states of matter. So these elements can be found in different forms at room temperature. Fluorine and chlorine are the first like invisible gases that you cannot see. So what about bromine? So bromine is a bit different because it's like a liquid, kind of like a water. What about iodine? Well, it's a solid, it's like an eye. So that is the reason why they are different in form, because how they strongly their molecules stick together, by which the bigger the atoms, the stronger the stickness. So perhaps you are wondering what are the colors for each element. So each of these elements has its own colors. For instance, chlorine and chlorine are lighter in colors, almost like a pale yellow like my outfit, but a more pale yellow or even greenish yellow. But as we go down the group, the bromine gets a bit darker, turning into a reddish brown liquid. And what about iodine? So iodine is the darkest of them with a deep purplish black colors. So these colors come from how their atoms interact with the light. Now let's take a look on to the melting point. Imagine these elements like ice cubes. Fluorine and chlorine melt really easily like an ice on hot days. What about bromine? Bromine needs a bit more of heat to melt like when it's a bit cooler outside. And iodine? Well, it takes a lot of heat to make it melt, like trying to melt a big block of ice. This happens because the bigger the atom, the harder it is to melt. So it's like an atom are holding on to each other tightly, making it tougher to break the bond. Just like the melting point, these elements also have different boiling points. Fluorine and chlorine turn into a gas with just a little of heat, while bromine and iodine need a lot of heat to become a gas. It's like you're trying to make a pot of water boil. Some things boil quickly and some takes longer to boil. So this happens because of something we call as van der Waals forces, which are like a tiny magnet that pull the atom together. The bigger the atom, the stronger these forces are. So it takes more heat to break them apart. You might be wondering too about the atomic size, right? So I have one metaphor. So imagine the atom is like a tiny ball of shelter. So picture this of atom is like tiny ball. As we move down the group, the balls getting bigger. Why? This happens because more layers of tiny particles are added to each ball. So the bigger the ball, the more stuff it can hold inside. This increase inside affects how tightly the atoms stick together and how strong the van der Waals force are. Now, think of density like how tightly packed the atoms are. The bigger the atom, the more tightly it's packed. So, what about bromine and iodine? Being bigger and denser than fluorine and chlorine. It's like trying to fit more toys into a big box. So, this happens because the bigger atom take up more spaces so they can pack together more. In exploring the reaction of group 17 element, whereas the chemical properties changes down the group 17, we encountered their integral behavior when they interact with water, metals, and also alkalis. So this interaction shed light on the reactive nature of chlorine, bromine, and iodine despite their own similarities in chemicals properties. Now let's take a look onto the reaction of group 17 with water. So when halogen like chlorine encounter water or dissolve in water, they initiate a reaction resulting in the formation of an acidic solution. For instance, the reaction of chlorine with water yields hydrochloric acid and also hypochlorous acid as represented by the chemical equation below. Furthermore, when halogen react with metals like iron, they form metal halide. For example, the reaction of iron with bromine generates iron 3 bromide, as shown by the equation. Now let's take a look at the third reaction of halogen with other things like alkali. So halogen exhibit reactivity with alkalis such as sodium hydroxide, producing metal halides and other compounds. So the reaction of the chlorine with the sodium hydroxide result in the formation of sodium chloride, sodium hypochlorite, and also water, which can be expressed by the equation as I stated below. Now, let's take a look at why group 17 elements are often referred to as an unstable element. Did you know that the reactivity of elements of group 17 decreases when going down the group? It's all about the atomic size that I have explained just now. So as the atoms get larger down the group, the valence shells move farther away from the nucleus. This weakens the nuclear attraction forces toward the electrons, making it harder to attract them to fill the valence shell. So as we descend the group, it's become increasingly difficult for this element to react. However, this decreasing reactivity doesn't mean we can take the safety for granted, because when handling this element, we need to be cautious and careful in the lab. In fact, it's had like acquired opposite properties, because group 17 just now I just said that they are very unstable and highly reactive. Even though their reactivity decreases down the group, they still possess the risk of mishandling. Like for instance, chlorine, it can react violently with certain producing the toxic fume of the substance. Therefore, safety measures like wearing a glove, face mask, and lab coats are essential to protect ourselves from hazard potential. Even though their activity may be decreasing, it's always better to be there for the safe than sorry when working this kind of element in the laboratory. We have come to the end of this session, but before that, let's recall back what we have learned and I explained just now. So in summary, group 17 elements, also known as halogen, exhibit such fascinating chemical properties that are essential in various industrial and everyday applications. From the fluorine to iodine, this element display distinct characteristics such as reactivity, states of matter, and coloration. So as we move down the group, atomic size increases, leading to decreased reactivity and changes in physical state. Despite their decreasing activity of reactivity, safety precautions remain crucial due to their potential hazard when mishandled. So overall, group 17 elements play a significant role in chemistry, industry, and also daily life, showcasing both their importance and essential for careful handling. So that's all for me. Thank you so much for listening to my lesson. So I hope you understand about the group 17. Thank you.